Okay, so we have this interesting question here. It says a body slides down an inclined plane which makes an angle of 30 degrees with the horizontal. Neglecting friction, calculate A, the velocity of the body after sliding 10 meters from rest. Then B, the time taken to slide the 10-meter distance. And we have our acceleration due to gravity G as 10 meters per second square. So let's just give a pictorial view of this whole question. So we could have our inclined plane as this. So let's assume this is the inclined plane. So I'm completing the whole triangle to make it a right angle triangle, and we have the object or the body on the inclined plane, and of course we have a particular distance 10 meters that the body will cover while it is sliding down. So but because it's going to slide towards the earth, then we know that it is going to accelerate. And what will make it accelerate? The force of gravity will make it accelerate. So it's going to accelerate because of gravity or due to gravity. And that's why we have the G here in the question. And now, the gravity ordinarily will act this way. So we'll have our G, just like how the mass will also act this way. But now we are looking at the gravity now, because we know that while sliding down, it's going to accelerate because of the force of gravity. So now we could actually get the component of the gravity that will act on the object, the component of the gravity that will go this way. So if the gravity will also go this way, based on the last video I did, I said the component of G moving in this direction that will make this object accelerate in this direction will now be G sine theta, while the component of the acceleration that will make it go this way of the G here will now be G cos theta. So ordinarily, if the object is going to slide down this way, the value of its acceleration will be G sine theta. And of course, we know the value of the angle that the inclined plane is making in the horizontal. They say it's making an angle of 30 degrees. So let me fix that 30 degrees there. So the object will slide down this way, and of course it is going to accelerate with this value. So it's going to be the value of G, which is 10 times sine 30, will be the exact value of the acceleration of the object while it is sliding down. So now let's see what we have, the parameters we have. So we know that the body slides down the inclined plane and it makes an angle of 30 degrees. I've written that here with the horizontal exactly. So neglecting friction makes our work very easy. Calculate the velocity of the body after sliding 10 meters from rest. So since they gave you, they said it's from rest, so definitely your initial velocity U will be equal to 0, because when an object moves from rest or starts from rest, your initial velocity is 0. So definitely, since they say you should calculate the velocity after the initial velocity is 0, because of the information here that says from rest, it means the velocity you calculate is your V, and that will be a question mark. And since it's sliding down, we have our value for G being positive and being this value here. So our G will now be, G is 10 meters per second square, but it's going to be, take this value since it's sliding down this way, sliding diagonally. So this will be the value of the acceleration. Our G is 10 meters per second square. So we'll just fix it in and calculate, and then fix 30 for the theta. Then we have sliding 10 meters from rest, so that's our S distance, which is 10 meters. So distance is 10 meters. So we can now calculate. So calculation will be easy here. We have our U, V, G, and S. So from the equations of motion, we know we have U and we are looking for V, we have G and we have S. So which of them has the U, V, G, S? This one is U, V, G, T. It doesn't go. This is U, S, T, G. No, we have U, V, G, S. but I think this third equation will work well. UVGS, exactly what we have here, UVGS. So this is our winner, so that's what we're going to use. So writing it out, v squared equals, I'm writing this one out because this one blends with the parameters we have. V squared equals u squared plus 2gs. So we now have v squared, what we're looking for, equals the u squared. Of course, we know our u is 0, so we're putting 0 squared plus, here our g will have this whole value because this will be the value of the acceleration of this object. So that will be 2gs means 2 times g times s. So I write 2 times this g. I'm writing this g sine theta now because that's the value of the acceleration of the object since it's going down diagonally. It's a component of this g. So times, I'm writing this whole value now, g sine theta, then times the s, which is 10. So rewriting it, I'll have v squared equals 0 squared is 0 and is nothing, so I'll be left with only just these values here. So that will be 2 times g, which is 10, times sine theta. Remember the theta is 30, so times sine 30 degrees, then times this 10. So we now have v squared equals 2 times 10 times sine 30 is 0.5, then times 10. So we now have v squared equals 2 times 10 is 20, then 20 times 0.5 is 10. Times this 10, you have 100. So we have v squared equals 10. Of course, you now have your v. This 2 moves over and becomes a power for 100. So if the v moves, if the 2, this power 2 rather, moves over and becomes a power for 100. So you now have 100. We'll now have a power. This 2 becomes a power, but when the 2 comes here, it inverts and becomes 1 over 2. So 1 over 2, and any number raised by 1 over 2 is actually the square root of that number. So yeah, you have to find the square root of the number. So v equals square root of 100. So our v equals 10. Square root of 100 is 10, so 10 meters per second. So that does it for the part A. So part A has been solved. So the part B now says the time taken to slide the 10-meter distance. So the time taken, so that will be t question mark. We now have our v as 10 meters per second. We still have our g as 10 meters per second square, and we still have our s as 10 meters. So which one will blend in now? We still have our u as 0 too. The u is still 0 because it started from rest. So which of the equations do we use now? So we might actually use, so let's see which one blends in this time around. So we have VUGST, VUGT. It still works out because we can still use this one because we're asked to find the time, and we have G, we have U, and we have V. So this one will blend in. So let's just write down V equals U plus GT. So writing that one out, just say V equals U plus GT. So V equals 0 plus, what's our G? Remember the G is this whole value here this time around. So that'll be 10, that'll be a G sine theta times T. Of course, the 0 here is nothing, so it goes. So you now have V equals, my G here is 10 according to the question, so we should use 10 for our G. Then times sine 30 degrees, that's the value for the angle, then times the T we are looking for. So what's our V? Our V in the first question we got 10 meters per second, so I'm fixing it there. So this will now be 10 equals to 10 times sine 30 is 0.5, don't forget that, then times T. So we now have 10 equals 10 times 0.5, that'll be 5, times t, that'll be 5t. Then divide both sides by 5. Divide both sides by 5. Then 5 in 10 gives you 2. So our t equals 2 seconds. So write t will now be equal to, this t equals to 2 seconds. So that does it. We have done this one also. So that's it about inclined planes. Interesting and very simple.